You have seen how to write a raw service server in the previous lesson. This time, you will write a service client in C++. To start, you go to your terminal, you go to the workspace, and then the package and the src folder. So this time, we're going to create a client and call it Euclidean distance server or client .cpp. Euclidean distance client .cpp. Let's make it executable. Euclidean and then client. All right, so we can now go back to the workspace and then launch VS Code from there. Beautiful. So we're going to close this, and this. And then we go to the client that we just created. All right. So remember, without the server, the client is not going to know where to get its response from. Okay, so we need the server to be running before we can use the client, and the client is the one that is going to give us the privilege to impute the response, to impute the request rather, and then we get the response back from the server or from the service server. Okay, so the first thing we want to do here is to add the header libraries. This is C++, so we have to include the ROS header library for C++, RCLCPP. Okay, so and then the next thing we want to do is to add the message file. This time around, we are not interested in TurtleSim because what we just want to do is to be able to pass in our request and then we get response from the server. So it's the server that is making use of the pose from TurtleSim. But here we just need to put in the header for the message file we're using. And the message file again is example interfaces /srv then /arc2 int.hpp. Okay, so let's add our chronoliterals that will be used for timing. So say namespace std chronoliterals. Now please, when I say std, I mean C++ std. I'm not referring to anything else. Okay, so we start our main function, then inside main say int argc comma, and then a char pointer argv. So those are the argument vector. Okay, so the first thing we want to do is to initialize the node. We're going to do init argc comma argv. So we have to initialize, that's the first thing. And then because we are going to enter two inputs and the inputs are the pose, remember we are going to get the TurtleSim pose and then we also impute the desired pose so that we can calculate the distance between the TurtleSim pose and our own desired pose. So on our terminal, when we want to run our node, we have to pass in two arguments, which are the pose of which are the desired pose, and it's going to be two arguments. So I'm just going to say, I'm going to put in the condition here that if you're not putting these two arguments, or if your argument is not 2, then it should give you an output to tell you that, hey, you need to put in 2 arguments here. Okay, so I'm just gonna say if RC is not equal to 3. So the first is your program, the C++ program, while the other 2 are the new arguments you want to put. So for instance, if the argument you want to put is 2, you write 3. If the argument you want to put is 4, you write 5. There's always this first argument, which is for the code you're writing itself, the file. So we say 3 because we need 2. Then we're going to put, okay, so RCL CPP. Now remember, RCL CPP info is just a macro that is used to log in messages. So if you want to log in messages onto your screen, you use RCL CPP info, and also you can use your normal C++ cout to log in messages on the screen. But we're going to use the ROS info. There are so many other things inside. We have the ROS debug, we have the ROS error, the RCL CPP debug and the RCL CPP error, and so many other things. So this one is used to log in information for users to be able to see what's going on. So we do RCL CPP, then get logger, so you can give your logger, any name, any kind of name you want to give your logger. It's more like you're giving it a title that, okay, this kind of log information I want to put now, it can be categorized under particular stuff. So I can just call this usage. So to say that, okay, this is the usage, this is how you use this information. So you say input, okay, it's going to be a string, input to coordinates. So input to coordinates. So basically what we're saying is that if you're not giving us 2 arguments, it's going to show you this error and tell you all this information, and then tell you that you have to input 2 coordinates, and then you might have to run the code your line again. Okay, so that's the condition. Now the next thing now is to create the node. So before we do that, let's create a node object and say std shared pointer RCL CPP and then the node. Then you give your node a name. We're just going to call our node. You can give it any name, doesn't matter. So we're just going to call it node, and then RCL CPP node make shared. So this is where we're passing the name of our node. So we're going to call our node Euclidean distance client. Okay, so remember the other node was Euclidean distance server. So this is Euclidean distance client node. And then we create the client RCL CPP. To create clients, you just use your client. Then you put in the type that your client uses. Remember, the type can be seen something like this on line 2. So the type is example interfaces, and then we have the SRV, it's a service file, and then we have add to ints, okay, followed by the shared pointer, and then the name of the client we're creating. So we're just going to call it client. So client is equal to, now because this line is getting longer, I'm just going to put it on the next line. So client is equal to node scope operator client, or it's create client, create client, and then the type example interfaces SRV, and add to int. Then the next thing is the name of the client we want to create. So the name of the client we want to create is called dist underscore 2 underscore points. Okay, so that's the distance between 2 points. So this is very essential. Then we create auto request. Now you need to understand that the server is not the one making the request. The request we had on the server is actually meant to get the request from the client. It's the client that is assigning the request value. It's the client that is actually giving us the kind of request we want. So I'm going to create a request file, and the request file is just going to be std make shared, or a request variable rather. Call it variable, you can call it object, srv add to int, and then because it's a request, we need to add this request part. All right, so this is the request. Now what we want to do with the request is to create a request and then access the object inside the request, or the variable inside the request. The first one is a, as you can see. So the first one is a, and remember from the introspection we did in the previous lesson, you can see that the two requests are a and b, while the response is some. Now what we want to do is we want the user to be able to pass in their request, and then we want to store it inside a. So to make the user pass in the request, we use the C++ keyword, which is toll. So what a toll does is to convert a string to a long integer. Now when we pass in the argument, the request argument on the terminal, it's gonna see it as a string. Even though it's a number, it's gonna see it as a string. So we need to take that number that looks like a string and make it a long integer. So that's what ATOL is going to do. It's going to take it and then make it a long integer. You can decide to use another thing. There's so many other things inside this ATOL thing. You can make it a double, float, it all depends on what kind of value you want to get. So we're just going to make it an integer, but a long type. And then to collect the data from the terminal, you use argv. So the first argument vector that we're going to collect is going to be stored inside request a, and then the next one, just gonna do cb. Okay, so the next one is b, and it's gonna be the second one. Okay, so it's going to take the second one and store it inside b. So that's how we can pass in the two arguments from the terminal, and then they are stored in a and b respectively. Now let's move on. So what we want to do now is to create a check. We want to be sure that the client is getting something from the service. The client is getting something from the server. So we're just going to say while the client, which can access, remember this is the client here on line 17. Okay, so while the client waits for service, so while it's not waiting, it's not been able to get service, so this is where the chronoliterals comes in. The 1s here is because we use the chronoliterals, so which stands for 1 second. Then we want to do something. What we want to do is that we want to say RCL CPP info. Remember, this is how you log information. Info. And what we want to put in our info is RCLCPP get logger. Want to log information. So when we get logger, we now want to put is, okay, we can say this is a C plus, this is a ROS kind of information, RCLCPP, and then we pass in the strings or what we want to output. So we're just going to say service not available, service not available, waiting again, service not available, waiting again. So basically what we are doing here is to wait for the client service, but we're saying that if the client service is not returning true after a second, then we want you to tell us that the service is not available. Now you can even put a further check here to see that is it actually that we're not being able to get a service, or is it that the ROS client library is not even working at all? So if the ROS client library is not even working at all, then the whole thing is not even working there. So we can decide to put more a kind of check and say, okay, if the ROS client library is not working, which is, remember, the ROS client library is RCLCPP. Okay, we can say if it's not okay, if there's something wrong that is making the ROS client library not working. Now we are saying if it's okay here, but we need to pass in the not sign to show that if it's not okay, meaning if it's not running, if it's not working, then we want to do something. We want you to tell us. No, this is just a way of like debugging or making sure that you have a good or proper information about what's going on. Okay, now this is an error. We can just say, not just an information now, an error. Remember I told you we have CLCPP, RCLCPP error. We have the info, the debug, and so on like that. So still gonna pass in the RCLCPP. It's still the get logger. Oops. It's still the get logger. Okay, and then you put in the name you want to give your error. So we're just gonna give it RCLCPP. It doesn't have to be RCLCPP. So you give the name you want to give your error, and then you can say interrupted while waiting for the service. Interrupted while waiting for the service, so it's exiting. All right, that looks good. Then remember to end with semicolon. Okay, and then we're gonna return 0. All right, so what we're saying here is that if ROS is not even working, if it's not able to communicate to ROS, then we want to say that interrupting while waiting for service, exiting. Okay, so that's an error information. But anyways, all this is just a check to know whether our service is when it's working or not. So, but if it's working fine, if it's been able to communicate with the server and get some bunch of information, then there's no need like running all this part of the code. So we can just continue with whatever we want to do. And what we want to do now is to create a result object or variable and store something inside. What we want to store inside is the client. Remember that the services can be used as a bidirectional asynchronous and synchronous messages in ROS2. So what we're saying here is that the client is asynchronous and it should send a request. So we're gonna put, what is the request? The request is the one we created up here, which is this auto request. Okay, so it's gonna get the request and then put them in result. So it's going to get a request, put them in result, and then we want to wait for the result. We say if RCLCPP spin on if RCLCPP spin. Is anything wrong? Okay, I need to put in this here. So if RCLCPP spin until future completed, and then you put in the two arguments it takes is the node and then the request in this case, which is result. So it's going to take in the node and the result, and if it's true, it's going to return something. So we want to check, is it a success? Are you being able to spin the node until you get information about the request? So if that's true, then we want to run something. So we're just going to put RCLCPP. Maybe I should just put this in the next line because it's going to be too long. RCLCPP future. Okay, future return code is success. So if it returns success, then we want to do something. If it returns success, then we want to do something. What we want to do is that we want to output the distance between the poles. So I'm just going to say RCLCPP info. And what you want to do is RCLCPP get logger. You have to use the get logger. So from the get logger, what type of error are you expecting? We can just call it, oh sorry, I said error, I mean information. We can just call it response, and then we say distance between. Now when we say distance between poles, then I'm gonna pass this this here, more like a placeholder to hold something for us, and we want, what we want to put there is result dot get. Then what we want to get is the sum. You remember the sum? Yeah, get the sum. So this line is going to do something. It's going to print out response. If everything is fine, it's going to print out response, distance between poles. So it's going to calculate the distance between the poles and then put the value here, just right here. But then what value is it going to put there? It is this result.getSum. Now result is this asynchronous client send stuff on line 32. So the result is going to communicate to the server and it's going to get the sum from the server. Remember the sum from the server? So it's going to get the sum from the server because the sum is the response. And the way the client works is that the client sends a bunch of information to the server, and the information the client is going to send to the server is line 21 and 22. It's going to send this request, and the request is the argument that we are going to put in from our terminal. So when we put in the request from the terminal, it's going to store it in A and B, and after storing it in A and B, it's going to come here and send that information to the server in an asynchronous way. It's going to send the information to the server and then wait to get the response. That's the function of this line 33 and 34. So it's going to wait to get the response. Now, if the response is successful, then that's when we want to run this. If the response is not successful, it's going to tell us service not available, wait again. But if what is causing the service or the response not to be successful is that the Rust client library is actually not working, which is the RCL CPP, maybe it's shut down. So what it's going to tell us is that interrupted while waiting for the service, exiting. So that's what it's going to tell us. So if it's successful, so this is like, this is a boolean. This one is going to return success, and this one is going to return true, and this one is also going to return true if everything is fine. But if things are not fine, it's not going to be the same. So it's going to be checking, is this true? Because this one is true, but it's going to be checking if this other one is true or false. So if it's not true, then this code is not going to run. This line 36 is not going to run. But if it's true, then it's going to tell us, okay, it's like I'm able to communicate with the server, and the server is able to, process my request and give me back the response. And the response is distance between poles is sum. So it's going to get sum and then print it out here. So, but what if there is an error? And that's where the else condition is going to come in. Remember, we said if the code is working fine, like if it's been able to get response, then we say, distance between poles is this. What if it didn't get anything from the server? We're just going to say else. We want to print out something, and else we just want to say RCL CPP. We want to log an information, and the information RCL CPP, get logger, and then we want to classify the type of message. We can call it anything. You can call it error, you can call it anything. Just gonna call it RCL CPP. And then I'll say failed to call service. Failed to call service. Okay, so the service is not working. That's the point. Okay, let's put it this way. So the service is not working. Then we continue with our code and say RCL CPP shut down. And let it shut down, and then you return 0. All right, fine. So this is the code. You include the header libraries. The chronoliterals is the one we used line 24 in the parentheses, just to give us the timing, 1 second. Okay, you initialize your node, or you initialize Rust, and then after that you check if the argument's being passed on the terminal. We're going to see this later, and we're going to test it. So you check if the argument being passed on the terminal is 2. That's why we have 3. By default, your file, your C++ file already takes 1 of the argument. So the other one is the remaining you want to use. So you check whether it's 2, and just like we have here, you can see it's 2. So if nothing is being passed, you say input to coordinates, and then you return 1. So it's just going to cancel the whole program. So the return 1 is just like, it's going to return a kind of error. Okay, so the next thing is you create your node, and then you call the node, you give it a name, Euclidean distance client. You create a client object, and the client object must have its own node, its own service that it communicates to. So that's distance between 2 points, which is these 2 points. So this here must have the same name with the Euclidean distance client server. So if the name is different, it's not going to know what to communicate to. So the name must be the same. Just like when we're dealing with topics, you have to have the same topics. If you want to publish to that topic with different nodes, they have to communicate with the same topic. So if the name is different, they're not going to communicate. Okay, so you make a request variable, and then the request can access the A and B variables inside the service structure. Remember the service structure, the int A, int B, and int sum. Okay, so while the client is waiting, is not being able to wait for the service. That's what this is saying. While the client is not being able to wait for the service, we want you to tell us that service is not available. But we're putting a further check. What if it's not just that it's not being able to wait for the service, but actually the C++ client library is not even working at that time? Then we want to get another message that tells us that interrupted while waiting for the service, exiting. Okay, so after that, we create a result object. Now, what a result does is to spin the node. Remember, spinning the node just means that you want to make the node run. Yeah, without spinning, it's not going to work. But we want to spin until we get a success. So if there's no success, then we want you to tell us that failed to call service. It's not being able to call the service. But if there is success, then return the result of sum. That's what this thing is doing here. So we're just going to save and hope everything is fine. We go to our CMake list to make sure CMake list, okay? So go to CMake list to set up things there. And the first thing we want to set up is we already have our example interfaces, okay, from the previous lesson. And then we have to just copy this. Okay, now let's create a new one. And instead of the Euclidean distance server, we have the Euclidean distance client. So this time it's client, and then we change this also to client. So we're adding our executables. We have to change this also. Client, okay. And remember, we don't need TotalSim for this guy, so we can just remove TotalSim. This guy doesn't really depend, the client doesn't depend on TotalSim. The client only depends on the example interfaces. All right, so I'm just going to remove that. Okay, so under the install, we need to add the client that we just created. So call it client, and that's all. That's all. The package.xml, we already added the example interfaces, so we don't need to do anything with it again. You can save your code, go back to the workspace, and then build with Qualcomm build. Build with Qualcomm build. And let's see if there's any error. Qualcomm is going to tell us. Qualcomm is a very powerful tool. Okay, so there's no error. Qualcomm build is successful. All right, so let's source our workspace again. Always remember to source. If you don't want to source every time, you can source permanently. Okay, so we can now run the code. Now, to run the code, we need to do some things. Let's open another terminal here. And then I'm going to split this. And then I'm going to split this. All right. So the first thing we want to do is to run our TotalSim. So ROS2 run TotalSim, and then the TotalSim node. Okay, so let's run our TotalSim and just drag it here. So the TotalSim is working fine. Then let's run the teleop key node. ROS2 run TotalSim. So that's the name of the package, and then the teleop key node. Total teleop key node. Okay, so the total teleop key is running also, but we don't need to do anything with the total teleop key at the moment. Now let's run our server. To run the server, we source our workspace first. Source total workspace, and then install setup.bash. Okay, we're just gonna copy that. Copy that, paste it here. Okay, so we're gonna source there too. Now let's run the server. Rust to run total control, and then we can run the Euclidean distance server. Because for you to run the client, the server must be running. So now it's ready. It's telling us get ready. Oh, sorry, ready to get distance between 2 points. Now let us run the client without passing the parameters or the arguments. So Rust to run total control, and then we have the Euclidean distance client. Now I'm just going to press enter. I won't pass the argument, and it's going to tell us impute to coordinates, and that is where that impute to coordinates is coming from, because we are not putting in the right argument, and you can see it will just exit. Okay, so now we need to impute two coordinates before we can get the distance. So I'm just gonna say, okay, let's input 4 and 6. 4 and 6. So 4 and 6, they are the new pose or the desired pose. But right now, the total is at location something like 5, 5. Like x is equal to 5 and y is equal to 5. But whatever, we're going to see it from the display here if we run this code. Now I'm going to press enter now and then see the changes. So can you see the client returned distance between poles is 1. And let's look at the server. The server is telling us ready to get distance between 2 points, and then it says incoming coordinates. Remember, this is the first coordinate here, which is the coordinate of the pose of the total, and this is our own desired pose. I put in 4 and 6 here, and you can see the 4 and 6. You can go back to the service server node that we wrote. You see that it's just working the same way. So the 4 and 6 here, and it's going to calculate the distance between this point and the new point we're putting here. But remember, normally you should have maybe 1 point something and something, because our code is returning an integer. So it's just going to truncate every other decimal part. All right. So I'm just going to put in something else. Let's say 11 and then 6. Or let me just use 8. We run it again. And then you can see it's telling us that the distance between this point, which is 5 and then 5, and the distance between this point to this point 11, 8 is 5. Okay, so I'm going to use this to move the total around so that we can change the pose, and then you will realize that our code is actually getting the current pose of the total and not just this default 555. So I'm going to run it again. Let's run this code again and see what's going to do. Okay, can you see now the pose has been updated, and it's telling us that the current pose is at 3.11 comma 8.28. So that's the current pose of the total, and then it gets this other pose from our own input. It calculates the Euclidean distance and returns 7, and you can see from our client we're getting back 7. Distance between poses 7. So that is how you can create the service server and service client to communicate between a particular service. The basic idea is you send a response, you make a request, and then you get a response. Remember, services are usually used when you need to make a quick request and response. It's not like topics that they need to always publishing and subscribing every time. For services, it's just for a short period of time. You want to make a quick task. You want to calculate the inverse kinematics of a robot. You just want to quickly do that and then return a value, and that's how you use it. Okay, so let's quickly introspect and see what's going on here. Rust topic list So these are the bunch of the list of topics we currently have. We have the Total1 CMDVL and so on. So let us check the services. ROS2 service. Now the Total1 CMDVL, color sensor, and pose, they are all running because we have our TotalSim running. So ROS2 service list. And then from here, you can see that we have the distance, these 2 points running as the topic, or sorry, as the service. So these 2 points is running. We can also check the nodes that we are currently running, ROS2 node list. And we can see these are the nodes that are currently running: the TotalSim, the Teleop Total, and our own Euclidean distance server. Now look at it. The Euclidean distance client node is not showing here. Why? Remember, it's a quick request and response. The service is always running, but right now the server is the server is always running, but right now the client is not running, and that's why we don't have anything. It's until immediately we run this part of the code, this part of the line, this one right now. If we run it, then the service node, the client node, is going to run shortly and then will terminate when the code is complete. So that's the beauty of services. We can also introspect with rqt. We can use rqt underscore graph. So you can use rqt underscore graph, and then it's going to show you everything running. So basically we have the TotalSim node. We also have the Total Teleop node, or the Teleop Total node. And then we have the Euclidean distance server node. So these are the nodes running, and you can use this one to see just the nodes. Okay, you can use this just to see the nodes, and then these are all the things running in this code right now. Okay, so this one is just going to show you the nodes only, and then nodes and topics. Okay, all right, so you have come to the end of the service and the service server and service client. In the next lesson, you will see how you can write this same code using the Python programming language.